everyone, welcome to The Explainer. If you're a dedicated aquarist, you already know exactly how demanding it is to maintain that absolutely perfect tank. Well, today, we're going to look at what might just be the ultimate quality of life upgrade for your setup. Auto Top-Off, or ATO, systems. We're going to break down exactly how they work, the clever technology behind them, and what you really need to look for to keep your tank thriving without the daily hassle. Seriously though, are you just entirely burnt out on those daily manual top-offs? Or maybe you're constantly dreading a tank crash from sudden salinity swings. If you're nodding your head right now, you are definitely not alone. We've all been there, right? Dealing with that relentless, everyday chore of replacing water while carrying around this constant, very real anxiety of evaporation, completely throwing off your tank's delicate chemistry. I mean, sudden salinity swings are literally the silent enemy of a healthy aquarium, and trying to manage them manually is just exhausting. Okay, let's dive into this. Here is our clear roadmap for today. We'll start by meeting the auto top-off, break down its 4 core elements, figure out how to choose the right sensor, and then dig into the critical safety features and maintenance protocols you absolutely need. So we're going to cover the brilliant automation, but also the crucial safeguards to prevent a flood. All right, kicking things off with Section 1, meet the auto top-off, your ultimate upgrade. Before we get into the nuts and bolts, let's establish exactly what this piece of equipment actually is. So what is it? At its core, an ATO is an automated system designed to maintain a perfectly consistent water level. But here's the absolute crucial point. It replaces that evaporated water with fresh water, not salt water. When water evaporates from your tank, it's just the pure water leaving. The salt stays right there. By automatically adding fresh water back in, the ATO steps in and perfectly prevents those dangerous salinity swings from happening in the first place. And that's exactly why we can easily frame the ATO as the ultimate hero of our story today. It completely ends that daily chore of lugging around heavy jugs of water. And honestly, more importantly, it provides a level of chemical stability that is incredibly difficult, if not impossible, to achieve by hand. It's really the perfect solution to the whole evaporation problem. Moving right along to Section 2, the 4 core elements, let's do a quick technical teardown to see how this builds from a brilliant concept into a highly functional piece of hardware. Because, an ATO isn't just some magic black box. It's an anatomy made up of 4 essential pieces of hardware that have to work perfectly in unison. First, you've got a reservoir holding your fresh top-off water. Second, a pump, typically a really small, efficient DC-powered unit. Third, you have the eyes of the system, which is your level sensor or float switch. And finally, the brain, a controller that decides exactly when to start and stop that pump. So how do those 4 elements interact? It's like a seamless cause and effect loop. Step 1, your tank's water level naturally drops from evaporation. Step 2, the sensor detects that tiny drop and instantly sends a signal over to the controller. Step 3, the controller turns on the pump, moving fresh water from your reservoir straight into the tank. And Step 4, the pump stops exactly when the sensor reads full. It's incredibly intuitive when you see the whole cycle laid out step by step like that. Next up is Section 3, choosing the right sensor. This is all about accuracy and reliability, because the success of your entire ATO system almost entirely comes down to the specific sensing technology you select. Now, what's really interesting about this slide is how easily you can map out the trade-offs here. Float switches, for instance, are super durable and simple, but because they're mechanical moving parts, they can get stuck on stray bubbles or floating debris. Optical sensors, they're incredibly responsive using light, but if those little optics get dirty or if your tank has heavy water turbulence, you're going to get false readings. And finally, conductivity probes. They use electrical properties to detect water levels, which is highly effective, but they demand really careful calibration and consistent maintenance to stay accurate over time. Which brings us to Section 4, safety features to look for, or, as I like to call it, preventing disasters. We need to shift gears to a safety-first mindset right now because an automated system pumping water without safeguards can quickly turn your living room into a swamp. When you're choosing an ATO, you have a few absolute non-negotiables. You absolutely want an independent, high-level safety switch, basically a backup sensor that shuts everything down if the main one fails. You also need runtime limits. If a sensor gets stuck, the controller will automatically kill the pump after a set time so it doesn't just run forever. Add to that flow rate matching, calibration settings, and controller alarms that actually alert you if a pump stalls or a sensor throws an error. These backups are absolutely crucial. But here's the catch. Even the absolute best hardware with all those safety features is going to fail if it's installed poorly. Proper placement is just as important as the features themselves. You have to mount your sensors where they won't be bombarded by bubbles or weird currents. Make sure your tubing connections are completely secure to prevent leaks. And, just use common sense to route all your power cables safely away from splash zones.
All right, let's transition into our final segment. Section 5, Maintenance and Overflow Prevention. Consider this your hero to zero warning.
Because an unmaintained ATO is basically a ticking time bomb. There's a massive difference between a system that happens to be working right now and one that works long-term. An ATO that merely pumps water today is great, but these systems will degrade quietly over time if you ignore them. Buildup sneaks onto sensors, pumps wear down. To ensure genuine long-term success, your routine has to include checking that mechanical sensor movement, wiping down those optical surfaces, inspecting the pump for blockages, and actually testing those safety triggers to make sure they still fire. Oh, and here is a super practical tip that will save you so many headaches. Always make sure your freshwater reservoir actually holds enough top-off water to last the entire interval between your routine checks. This is incredibly important to calculate before you go on vacation. You do not want that pump running totally dry while you're traveling. Also, right after you install this whole shebang, don't just walk away. Follow these vital best practices. Start with short observation periods. Actually stand there and watch how quickly the pump responds when the water level drops. Verify that the tank returns to the exact intended level smoothly without overshooting. Doing this helps you catch an incorrect sensor placement or overly aggressive flow early on, way before it causes a problem while you're asleep. So I'm going to leave you with this final provocative thought to chew on. Is your automated setup truly secure? Or are you literally just one dirty sensor away from a disastrous overflow? An ATO is a fantastic, life-changing upgrade for sure, but true convenience only comes when it's paired with real reliability. Hopefully, this explainer has given you the exact roadmap to rethink your maintenance routine and keep your tank perfectly balanced. Thanks so much for joining me.